Okay. So the partial molar quantities, we had started with the partial molar volume. Yeah, right? Okay, thanks. So, and I think we had defined that as V equals or Vj equals change in the total volume divided by the change in the number of moles of that particular component J, where pressure, temperature, and the rest of the constituents are held constant. So, if I were to think of uh, the total change or the composition of some system, right? Then let me again look at this particular graph. If I say that I am at some mole fraction of ethanol, let's say 0.4, okay, and I tell you that it has Na numbers of water molecule and Nb moles of ethanol. And then I ask you what's the total volume of the system. The answer would be the partial molar volume of water times Na, number of moles of water, plus the partial molar volume of ethanol times the number of moles of ethanol. Yeah? So, I just said 0.4, but it's true for any composition. If you look at the graph. So what I have is partial molar volume of component A times Na plus partial molar volume of component B times Nb. This would be my total volume. Right? And now, how do I arrive at this? Is also very interesting because, yeah, the guy in the green t-shirt, tell me if this is not understandable or too easily understandable. Huh? Or you, oh, okay, you want the attendance, that's why you're here. And I keep forgetting it, huh? That's very bad on my part. So, if I think of a change, a very small change in the volume dV, the total volume dV, then that change I would define as the partial molar volume of A. No, n prime I don't, so I'm just thinking of a two component system and we'll extend it times dN A plus change in this by dN B, pressure, temperature, Na, change in the number of. So that's how I should be writing, right? And you know that the partial molar volume changes as I change the constitution of the system. So, if I think of changing the number of moles from 0 to some mole Na and 0 to some mole Nb, I have to make sure that this Na and Nb are very, very small quantities compared to the entire total volume. In that case, if these are very small, I can assume this to be constant. What I am saying is that the composition of the system does not change much when I add Na number of moles and Nb number of moles. So the constitution is constant. If that is true, I can integrate over the entire expression, and if this thing comes out to be constant, which it does because I am not changing too much number of moles, then I just integrate over dNA from 0 to Na, and I get the same expression that is written on top. Otherwise, also, if you think that is, it's not a small number. Okay, let's let it be a big number. Then also, what you need as per this figure, as you've already done it, what you need is just the value of the partial molar volume times the number of moles of component A, and at the same concentration, the value of the partial molar volume times the number of moles of component B. That gives you the total volume. So what you have is essentially, and if you realize this is a change in volume, right? This change in volume needs not necessarily be positive. Okay? You already see that when I put 1 mole of water into lots and lots of ethanol, then the change was 14 mil, not 18. The change was much less than 18. Still, it was a positive number. But there are other examples, for example, magnesium sulfate, which gives you a change of minus 1.4 milliliters. If I put 1 mole of magnesium sulfate to a large quantity of water. And that reason is because this magnesium ions, they tend to surround a lot of H plus ions, and then, the OH minus ions, and the sulfate ions tend to surround the positive ions, and the pattern becomes much more compacted than it was originally only for water. Yeah? Mostly that water is in that cage-like structure that I told you earlier, and it becomes more compact, which means that the total volume of water plus magnesium sulfate gets reduced. Yeah? And then my partial molar volume also gets reduced. I mean, it's a negative number. So could be, let me just, partial molar volumes could be negative in certain cases. Of course, volumes can't be negative, it's only the partial. Yeah, another thing, if you realize in this diagram, then that is dV by dN. So essentially, it's the slope of this curve. The partial molar volume is essentially the slope at that particular point of the curve. Of actually the total volume, not this one. This is the partial molar volume versus mole fraction. If I plot the total volume, then it's the slope of that curve with respect to whichever constituent, the number of moles of whichever constituent you're talking of. Okay. Now, if I can define partial molar volume, I'm sure I can define more and more number of partial molar quantities. One of those you've seen earlier. So let me just go back from there. What we saw was the total volume was equal to partial molar volume of A plus partial molar into moles of A plus partial molar volume of B into moles of B. If I had a pure component, what would be the partial molar volume? Equal to the molar volume, which is the volume of that component divided by number of moles, right? So you've seen something in the previous lectures which we have defined earlier. What is that? The chemical potential, which is the Gibbs free energy, the molar Gibbs free energy, right? Now, volume was more intuitive to understand, so I could do that. I can't do that same thing with the Gibbs free energy, but definitely I think you will agree that let me write the total Gibbs free energy as chemical potential of A times number of moles of A plus chemical potential of B times the number of moles of B. Even before that, maybe I could define dG is equal to mu A dNA plus mu B dNB. Yes? Right? What does this first expression tell me? How have you been writing dG till now?
VDT minus SDT.
What should I do with this one? Should I equate that or?
Add both of them.
Very nice.
Let me just make a dot 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 saying that let it be n number of components.
Right? I'm not yet done that, but could you tell me what would be the definition of mu A?
The partial model gives the job of the
So let me write it like that. Mu of component J is equal to del G by del N of J at wow. Yes, rest of the components being held constant.